Hello friends, how are you all today? I hope that you had enjoyed the two activities using these plastic strips from the mathematics kit that we had performed in the previous episode. In the first activity, you had learned to construct and measure the various kinds of angles, and in the second activity, you learned to verify the different pairs of angles formed when a transversal intersected two parallel lines. Let us use the same plastic strips to verify some properties of triangle. For this, join 3 plastic strips with 3 full protectors using the 3 screws to get a triangle like this. How many angles do you see in this triangle? We have 3 interior angles, angle 1, angle 2 and angle 3. Now let us measure these 3 angles and see what I get. Angle 1 measures 45 degrees. Angle 2 measures 65 degrees. And angle 3 measures 70 degrees. If I add, I get that 45 plus 65 plus 70 is equal to 180 degrees. Thus, the sum of the 3 angles of a triangle comes out to be 180 degrees. You can change the shape of the triangle using these moving plastic strips and then also verify that the sum of the interior angles of the triangle will always be 180 degree. Hence, interior angles of a triangle always add 180 degrees. Now let us prove another property using the same triangle. Angle 4 is the exterior angle of this triangle. Measure angle 4. Angle 4 measures 110 degrees. Angle 1 and angle 2 are the interior opposite angles to this exterior angle. The sum of angle 1 and angle 2 will also be 110 degrees. So, we conclude that this exterior angle of the triangle will be equal to the sum of the two opposite interior angles. You can change the shape of the triangles and again verify the same property. The property will always remain the same. Let us prove another property using an isosceles triangle. A triangle which has 2 equal sides is an isosceles triangle. This is an isosceles triangle where this side is equal to this side. Let us verify the property that the angles opposite to equal sides will always be equal. This angle is opposite to this side and this angle is opposite to this side. Measure this angle and measure this angle. Since these are angles opposite to equal sides, you will find that these two angles will be of the same measurement. Thus, we can say that angles opposite to equal sides will always be equal. You know, you can prove this the other way around also. You can also prove that angles with equal measure will always have equal opposite sides to them. Let us now prove a few properties of equilateral triangles. But what is an equilateral triangle? A triangle which has all the 3 sides of equal length is called an equilateral triangle. Using the moving plastic strips, make an equilateral triangle and let us verify the property that equilateral triangles are also equiangular. For verifying this property, measure the 3 interior angles of the triangle. You will find that all the 3 angles are of equal measure. Hence, we have verified that an equilateral triangle is also equiangular. Remember, the converse is also true. Do you want to now verify properties using scalene triangle? What is a scalene triangle? I hope you all know it. A scalene triangle is a triangle which has none of the sides equal. So, using the plastic strips, make a scalene triangle. This is a scalene triangle in which none of the sides are of equal measure. In this triangle, if this is the side with largest measurement, then the angle opposite to this side will be the largest of all the three angles. We can also verify that the sum of these two sides will be greater than this side, the sum of these two sides will be greater than this side, and the sum of these two sides will be greater than this side. This will be true for any triangle you make using these moving strips. Thus, we verify that in any triangle, the sum of two sides will always be greater than the third side. Isn't it interesting to verify these properties? One last property which I would like to share with you. Make a right angle triangle using these moving strips. This is a right angle triangle with this angle as 90 degree. We can verify by measurement that the sum of the square of the side opposite to the right angle is equal to the sum of the squares of the other two sides. This Pythagoras theorem can be verified by making right triangles of different dimensions using these moving plastic strips. Now, I think you have learnt a few properties of triangles. Try to verify few other properties on your own, and we will move on to properties of quadrilaterals. For this, make a quadrilateral using 4 plastic strips, 4 half protractors, and connect them using 4 pair of screws. If you measure the interior angles of the quadrilateral, you will find that the sum comes out to be 360 degree. Even if you change the shape of the quadrilaterals using these moving plastic strips, you will see that the angle sum property of quadrilateral always remains the same. Let us now make a parallelogram with the help of these moving strips and protractors. This is a parallelogram. Measure all the 4 sides of the parallelogram. This side measures 19 units. The opposite side also measures 19 units. This side measures 11 units. The opposite side also measures 11 units. Hence, we can infer that in the parallelogram, the opposite sides are always equal in length. Now, let us measure the interior angles of the parallelogram. Measure the 4 interior angles of the parallelogram. This angle measures 80 degrees. The opposite angle also measures 80 degree. This angle measures 100 degree. The opposite angle again measures 100 degree. Thus, we infer that in a parallelogram, the opposite angles are always equal in measure. By measurement, you can also see that the diagonals of the parallelogram are bisected at their point of intersection. Now, make a rhombus using the moving plastic strips. This is a rhombus. You can verify many more properties of rhombus using this, like opposite angles of a rhombus will always be equal in measure, and using a full protractor, you can see that the diagonals bisect each other at 90 degrees. You can make many other rhombus of any dimensions you want and see that all these properties will be verified in all the rhombus you have made. Now, using the plastic strip, let us now make a rectangle and verify its properties. This is a rectangle. Let us measure the sides. Opposite sides of the rectangle are always equal in length. This side measures 19 units. This side also measures 19 units. This side measures 12 units. The opposite side also measures 12 units. Hence, in a rectangle, the length of opposite sides is always equal. Also measure the internal angles of the rectangle to see that each angle measures 90 degree. By measurement, we can verify that the diagonals of the rectangle are bisected at their point of intersection. Now let us make a square and verify few of its properties. This is a square. Let us measure all the four sides of a square. The lengths of side of a square are always equal. This side starts from the 5th unit and ends at the 19th unit. So, the length of this side is 14 units. Similarly, by measurement, we find that length of all the three sides of the square is also 14 units. Four interior angles of the square are right angles. Now measure the four angles of the square. You will find that each angle measures 90 degree. Each angle of a square is a right angle. By measurement, we can also verify that the diagonals of a square are equal in length. Using this full protractor, we can see that the diagonals of a square are bisected at right angle. You can change the dimension of the square and verify the properties again. So now, have you seen how many properties have we verified just by using these moving plastic strips and protractors? So weren't these activities interesting? You can also try to verify some other properties of triangles and quadrilaterals using these plastic strips. And I'll be back in the next episode to perform more activities using this mathematics kit. Till then, bye-bye.